Welcome students to the next video of Trigonometry Basics. Now we are going to learn about trigonometric identities. But let's revise first what we have learned in the first video of Trigonometric Basics. Here on screen you see a triangle PQR in which angle Q is 90 degree and angle R is theta. Side PQ is opposite side, which we are going to call it O. Side QR is adjacent side, which we are going to call it A. And side PR is hypotenuse, which we are going to call as H. So as per we have learned in video 1, sin theta is equal to O upon H. That means PQ upon PR. Sin theta is equal to opposite side upon hypotenuse. That means PQ upon PR. Cos theta is equal to adjacent side upon hypotenuse. That means QR upon PR. And tan theta is equal to opposite side upon adjacent side. That means PQ upon QR. Cosec theta is equal to hypotenuse upon opposite side. That means PR upon PQ. Sec theta is equal to hypotenuse upon adjacent side. That means PR upon QR. Cot theta is equal to adjacent side upon opposite side. That means QR upon PQ. Now we have also learned in the last session that sin theta and cosec theta are inverse. Cos theta and sec theta are inverse. Tan theta and cot theta are inverse. You can see from this again, sin theta is PQ upon PR, cosec theta is PR upon PQ, cos theta is QR upon PR, sec theta is PR upon QR, tan theta is PQ upon QR, cot theta is QR upon PQ. Now I want you to focus only on three trigonometric ratios: sin theta, cos theta and tan theta. What is sin theta? PQ upon PR, and cos theta QR upon PR. Let's divide sin theta by cos theta. What we get is PQ upon PR divided by QR upon PR. As PR is common on both sides, it gets cancelled out. So what we get answer as PQ upon QR. But PQ upon QR, if you pay attention, that is tan theta. That means sin theta upon cos theta is equal to tan theta. Let's focus again on sin theta and cos theta and now cot theta. Why? Let me explain to you. Earlier we divided sin theta by cos theta. Now let's divide cos theta by sin theta. What is cos theta? QR upon PR, and sin theta is PQ upon PR. Again PR is common denominator, so it gets cancelled out. So what is left is QR upon PQ. But if we look, QR upon PQ is cot theta. So cos theta upon sin theta is equal to cot theta. Easy? Now let's prove first trigonometric identity, which is sin square theta plus cos square theta is equal to 1. We are going to prove. Let's see how. So what you are seeing on screen is a right angle triangle. So Pythagoras theorem gets applied to right angle triangle. What is Pythagoras theorem? It says side 1 square plus side 2 square is equal to hypotenuse square. That means PQ square plus QR square is equal to PR square. Let's divide both sides by PR square. So it becomes PQ square upon PR square plus QR square upon PR square is equal to PR square upon PR square. But if you pay close attention, PQ upon PR. PQ is opposite side of theta and PR is hypotenuse. So what is opposite side divided by hypotenuse? It is sine theta. So that means PQ square upon PR square would be sine square theta. Similarly, QR square upon PR square. That means QR is adjacent side, PR is hypotenuse, which is nothing but cos theta. But since this is square both sides, so we will be taking cos square theta, and PR square upon PR square is going to cancel out. That means it remains as a 1. Hence we prove sin square theta plus cos square theta is equal to 1. Let's prove second trigonometric identity, which is 1 plus cot square theta is equal to cosec square theta. To prove this, we are going to use first trigonometric identity, which is sin square theta plus cos square theta is equal to 1. Let us divide both sides by sin square theta. What we will get? Sin square theta upon sin square theta plus cos square theta upon sin square theta is equal to 1 upon sin square theta. So first thing, it is going to get cancelled out, sin square theta upon sin square theta. So we are going to get 1 here. Cos square theta upon sin square theta. What is cos theta upon sin theta? It is nothing but cot theta. So we are going to get cot square theta. And we have already seen 1 upon sin square theta is nothing but cosec square theta, because sin theta and cosec theta are inverse. 1 upon sin theta is equal to cosec theta. Hence 1 upon sin square theta is equal to cosec square theta. So we have proved second trigonometric identity, which is 1 plus cot square theta is equal to cosec square theta. Let us learn third trigonometric identity, which is 1 plus tan square theta is equal to sec square theta. Let's prove this. To prove this, we are going to again use first trigonometric identity, which is sin square theta plus cos square theta is equal to 1. Let us divide both sides by cos square theta. What we are going to get? Sin square theta upon cos square theta plus cos square theta upon cos square theta is equal to 1 upon cos square theta. Now recall what we have seen in the first sections. Sin theta upon cos theta is nothing but tan theta. So sin square theta upon cos square theta is equal to tan square theta. Cos square theta here gets cancelled. So we get 1 and 1 upon cos square theta. What was 1 upon cos theta? It was sec theta. So 1 upon cos square theta is nothing but sec square theta. So we have proved 1 plus tan square theta is sec square theta. Like and subscribe for watching more videos and solve numericals on this topic. Thank you.